Anna Pakhomova, and I work as a beamline scientist at the European Synchrotron Radiation Facility, or ESRF. Through my academic career, I had to travel quite a lot through different countries, cities, and institutions. Originally, I'm from Russia, from St. Petersburg, and I have performed all my studies, my bachelor, master, and PhD studies at the geology faculty of St. Petersburg State University. And during these studies, I was specializing in crystallography, and I was investigating crystal structures of different minerals at ambient conditions. During my PhD studies, I shortly went for a visit to Bern University, and this experience has motivated me to pursue my career abroad. And therefore, for the first postdoc, I went to Bayerisches Institute in Germany, and there I entered the field of high-pressure crystallography. After my first postdoc, I entered the field of synchrotron research. And firstly, I worked as a scientist at the DAISY. It's a synchrotron in Hamburg, in Germany. And afterwards, I moved to Grenoble, where I'm currently working at ESRF. In my research, I'm curious to know how different rock-forming minerals evolve their crystal structure along with the pressure. And this knowledge is essential to understand the internal structure of the Earth and other planetary bodies. In my research, I mostly focused on the Earth itself and as well as internal structure of icy moons of Jupiter and Saturn. It's a very interesting question how we can recreate high-pressure conditions in the laboratory. And in order to do so, we use a small and elegant and at the same time very powerful device that is called a diamond anvil cell. And it's composed of the two diamonds with the cut tips that are located opposite to each other. And by placing a sample in between two diamonds and by bringing diamonds close to each other, we can expose the sample to high pressures. And nowadays, with the usage of such device, we can quite easily create pressures comparable, for example, with the pressures in the center of the Earth. In order to investigate the evolution of crystal structure with pressure, we need to use X-rays of high brilliance that are nowadays available at European Synchrotron Radiation Facility. Work style at synchrotrons is very different from universities and research institutions. For those who are not familiar, synchrotrons are large-scale facilities, they're big machines that deliver high brilliant X-rays to a number of beamlines. And actually on this photo you can see how the electrons are produced in a linear accelerator, and then they are accelerated in a ring and then delivered to the storage ring where they reach the speed of light, and then X-ray beam of different energies is delivered to a number of beamlines, and here is the ID27 beamline where I'm working. And scientists from all over the world, they are coming to synchrotrons to perform their experiments, and these scientists are called users. It's a very dynamic job at synchrotrons. A lot of people with different projects and backgrounds are coming to perform their experiment, and it's our job, the job of beamline staff, to help to prepare the setup and to help users to conduct the experiment at our beamline. At the same time, it's also an intense job. The synchrotron operates 6 days per week, days and nights, also during the most of the holidays. And beamline staff has to be able to react quickly in case there are some challenges appearing during the experiment. In parallel to the support of users' experiment, each beamline staff has also its own in-house research program. And in my case, I also have a postdoctoral student and a PhD student that I supervise. and who helped me to answer different questions in the field of high-pressure crystallography. From my experience, I never felt a bias against me as a woman, and I was lucky to work in healthy and open-minded environments. However, nowadays there is a tendency in science to equilibrate number of women and men, and I think sometimes methods are used for this a bit too extreme. And for example, in the past I had experience of being called to a job panel, for example, as being a female, and during this job interview we had to interview a female candidate that was completely not competent. And I think this positive discrimination is not beneficial neither for women nor for men, and I believe that in science competence and excellence should be over the gender. And I believe that the question of equal roles and equal opportunities should be addressed not at the professional level where we already are, but much earlier, starting in the kindergartens and schools. Another problem of being a parent in science arises from the fact that a lot of scientists are immigrants and they don't have support from parents or from the extended families. And therefore it can be a challenge of leaving for the conferences or for work trips. And in this light, I think it's very important, and nowadays there are already actions regarding this, that the parents in science are supported, and there is a child care offered at conferences, workshops and other scientific events. I love my job, and I'm sincerely convinced that it's one of the best professions I could have in my life. I'm happy to contribute to exploration of our world, and there are still so many questions to be answered. The only downside of being a scientist is the lack of stability in life. I don't have a permanent job yet, and that means in a couple of years, most probably I will have to move again to another city or another country. But for now, I keep enjoying my work, and ESRF is the perfect place for my career progress.